the last of our transcendental functions here. In regards to, we kind of already talked about the end behavior in terms of what these functions look like, but just as a reminder, the function f of x equals e to the x looks like this with a y-intercept of 1, and the graph f of x equals e to the negative x is just a reflection with a y-intercept of 1 as well. And so these are the functions that we are talking to. And the same thing goes, this is also basically what the graph of y equals a to the x looks like, and what the graph y equals a to the negative x looks like, where we have a different base. So the base, the premise of the graph really doesn't change. The y-intercept is 1 in both cases. How much it's stretched to the left and to the right is really the only difference, that when you change the base from e to a, because e is a constant. So, it is the natural base, which can go into the formula. So I usually refer to this as the copy-paste derivative. So the copy-paste derivative, it's a nice derivative where you're going to copy exactly what you see. So it's almost like a chain rule version. When you copy, you always make sure you copy and paste the baby. You can almost think of the entire thing as its own baby, because the derivative of itself, the derivative of an exponential is actually itself. So the derivative of e to the x is e to the x. It's not a mistake. It's itself. The function value itself is also its rate of change. So in other words, if I were to look at this graph up here and I were to do right here, the slope of that tangent is also 1 at, or sorry, is e to, because is e to the 0, which is 1. So at the y-intercept, you can kind of see there at that point right there, the slope of the graph is actually 1, because the x value is 0, so e to the 0 is 1. Not only is the function value 1, but the slope, the derivative at 0, is also 1. Okay, so copy and paste. The derivative of e to the x is e to the x. And more importantly, the chain rule version, now that you got a taste of the chain rule version, what is going to be the derivative of e to the u? Remember, it's copy and paste. What do you think it's going to be?
E to the u.
E to the u times remember, it's chain rule.
UE.
Du dx times the derivative of the baby. So you copy the exact thing you see, and then times the derivative of the baby. So you have to multiply by the derivative of what's up top. Okay, and the same thing for e to the x is really just e to the x times the derivative of x, and the derivative of x, of course, is just 1. So it's e to the x times 1. So the chain rule is copy paste. Don't forget the baby. Look at some examples. Yeah, I wrote an example like it was an exponential. So we're going to find f prime of x My first example is f of x equals e to the 3x. What is f prime of x? Yep. Just for the notes purposes though, I want to write it as e to the 3x times 3. But as was written in the chat, this is f prime of x equals 3 e to the 3x. So that 3, sometimes we just write that 3 right in front. Once you get comfortable with these ones, I go with 3 e to the 3x. But for notes purposes and following the rule, e to the 3x times 3, and then of course we can simplify that. Perfect. B. So now the derivative of the baby could get a little bit more difficult, okay? So f of x equals e to the square root of x. Now we got these type of problems when we were dealing with logarithms last night where the baby itself was a square root, so sometimes we just need to clean that up. So what do I do in terms of finding this derivative? What do I do?
Do you make the radical?
Yes, so I want to clean it up. I want to make it calculus friendly. I want to make the radical rational. So e to the x to the 1/2. Good, so I rewrite the function first. Now I'm going to take the derivative. So the derivative of this would be,
Wait, Mister, can you repeat that?
the derivative is, question mark, I'm asking you. What's the derivative? That's all I'm asking. So first off, we get the first piece, which everybody should be able to get. Literally it's copy paste. That's what I'm telling you, it's copy paste. So the first part of derivative we should get correctly. So e to the x to the 1/2 times, and you got to be careful, it's times, no, it's times the derivative of x to the 1/2. All right, times the derivative of x to the 1/2. Now, typically we don't write it like this when we do our work, but this is e to the x to the 1/2. Now, what is the derivative of x to the 1/2? Make sure you don't leave any terms behind. So Farida gets the first part, but she's missing some terms. She's missing a lot. She's missing a good chunk, a very important chunk. There we go. X to the negative 1/2. You gotta take the derivative, all right, of the entire thing. Okay, so it's not just you can't. This like I said, this is the easiest derivative right here. So it's a very straightforward algorithm. You copy exactly what you see. You differentiate the top part. So what is the derivative of x to the 1/2? And boom. And so that's the answer. Of course, this simplifies down to e to the square root of x all over 2 square root of x. That's how you would simplify that. All right, because the x. Now, in for the AP exam, typically simplifies back to radical form for 1/2 and negative 1/2. So in other words, you would see square root or 1 over square root for these ones, okay? So typically you would see it rewritten or so as some function in there as 1 over the square root. So, but all the others would just, so if it was 3/2 power, we just leave 3/2 as 3/2. Okay, so in other words, blah to the 3/2, we just leave it like that. All right. If it's not 1/2 power, we're not going to worry about it. It's not going to simplify for us. Now, these were functions that were exponential first. So this example here was exponential to a power chain rule. All right. This was an exponential to a power rule. Basically, that's what it was. But at the outside function was exponential. But now sometimes the baby is exponential. Example C. F of x equals cosine of e to the x. So this is not an exponential at its base. This is a cosine derivative that goes into an exponential for the chain rule. So this is a chain rule a cosine chain rule problem with a exponential baby. So what is the derivative of this function? This is a cosine function with a chain rule. The first part is sine. Very, 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 very close. Negative sine. There you go. The first part is negative sine of e to the x, but that's not the answer. That's not the final answer. Don't forget the baby. Times
1
no,
x
no,
ex
e to the x. The derivative of e to the x. So it's negative sine e to the x times the derivative of e to the x, which we just learned is e to the x. The derivative of e to the x is e to the x. So the first e to the x is the baby. The second e to the x is the derivative of that baby. And so you got to understand that these two e to the x's are actually different e to the x's. One of them comes from the base function, and one of them comes from the derivative of that one. And we can write this as negative e to the x sine of e to the x if we wanted to. D. Well, what about if I flipped it and I said e to the cosine of x? Now this is an exponential chain rule with cosine as the baby. So it's exponential first. So what's the derivative? What's the first part of the derivative? Pulling teeth here. So since it's exponential at its heart, it's the copy paste.
So would it be e to the power of cosine of x times, and then you put the negative sine of x.
Times negative sine of x. Yep, times the derivative of cosine of x. Copy and paste. Times the derivative of the baby. Copy, paste what I saw, times the derivative of cosine of x. F of x equals e to the x plus 1 over e to the x. Now, what type of problem is this?
Quotient.
Quotient. So it's quotient as written. All right. Now, if you feel comfortable in just going towards the quotient rule, you can just do the quotient rule and you would get your answer. All right. But the problem here is that if you do this problem with the quotient rule, you might not see the answer on a multiple choice. So if it's just a regular problem, I would just do this as written. So let's do that as this. So f prime of x equals, so u prime v minus v prime u over v squared. I get the derivative of u, which is what? What's the derivative of e to the x plus 1? What's the derivative of e to the x plus 1? E to the x. Times v. All right, what's v?
EX.
E to the x. Ex is something different. Ex is something different. All right. Next thing. Next piece. Before that, Farida. Minus e to the x, which is derivative of e to the x, times what?
EX plus 1.
E to the x plus 1. Ex is something different.
So everything's over to E power X parentheses square.
Very good. Now, that's the answer. Okay. It's ugly though. So we need to simplify that down. So this is the same thing as e to the x times e to the x. All right. That's e to the 2x minus e to the 2x e to the x all over e to the 2x. The e to the 2x's cancel each other out, giving me negative e to the x over e to the 2x, which is e to the what?
2x. No, not 2x. Only x.
No. How do we subtract exponents? Subtract? Well, yeah. So, I mean, how do we divide, I meant to say. So, yes, subtract the powers. So, what is x minus 2x? So, negative. Sorry, I forgot the negative in front.
Negative x.
Negative x, which gives me negative 1 over e to the x. That's how you clean it up. That last part is all algebra. And the truth is that algebra part is what's going to set a person who's going to get a 5 from a 3. In terms of nailing that algebra part, it's not really my priority to spend a lot of time on it because I don't know if the exam is going to be even have multiple choice. I'm assuming it will, but typically, if it doesn't, we just need to make sure we can take a derivative, and that's what I box is the most important rule. Now, I had noted that I said f of x was equal to e to the x plus 1 over e to the x. We could have simplified this to e to the x over e to the x plus 1 over e to the x, which is 1 plus e to the negative x. I could have done it this way. This is an alternative problem. So f prime of x would be 0 plus e to the negative x times the derivative of negative x, which is negative 1, which gives me negative e to the negative x, which is negative 1 over e to the x. The power of algebra. All right? I want to note on that I used algebra up front to clean up the function, which makes it more efficient and easier to differentiate, but it's not a requirement. This is the answer. This is a proper method. For most of you, you just want to say, oh, it's a quotient rule problem. I'm just going to deal with it as a quotient rule problem and follow the rules. Be algorithmic. Follow the steps. U prime v minus v prime u over v squared. Oftentimes, it'll be better for the majority of students to not try to overthink about how you can do it because you might make an algebra mistake. However, if this is a multiple choice problem, doing it this way is most likely going to lead to the correct answer a lot quicker and actually finding the right answer for the simplification. Because the simplification after you use the quotient rule, when you didn't need to use the quotient rule, is a lot more complicated. But if it's not a multiple choice problem, then I would just quotient rule it. And the reason I say you want to be careful is because I can give you this example. F of x equals e to the x over e to the x plus 1. This is an example where people will try to simplify it, and you're wrong. This cannot be simplified or manipulated. This cannot be algebraically manipulated. And this way, when the denominator has multiple terms, you cannot. But I get a lot of students when I try to teach, I try to focus on this good algebra skills and saying how that makes stuff so much more efficient. And then they try to apply the things that we did here to this problem down here. And now you've done some really bad algebra, and now you have no chance at doing the correct answer no matter how good your calculus is, because you make a mistake in the first part and you're kind of shot yourself in the foot. So f prime of x, this is still quotient rule, u and v, and this is quotient, u prime v minus v prime u over v squared. So what is the derivative? I like to do this sometimes. That's how the quotient rule is always going to look. It's a derivative times a function minus a derivative times a function over a function squared. So what's u prime?
One over e.
No. What is u prime? Yeah, so yeah, Frida, you're giving me a lot more. But yeah, so e to the x is my u prime. The derivative of e to the x is e to the x. As simple as that. You cannot do algebra. So I think, Darwin, you were trying to do some algebra of doing 1-overs. Yeah, there's not even no functions. Neither of the functions is 1 over. The functions are e to the x and e to the x plus 1. So you should only be writing those functions or those functions derivatives. And as Frida said, times e to the x plus 1, all right, minus the derivative of e to the x plus 1, which is, we've already got those answers. We've already got all the derivatives and stuff. It's just moving them around. Which is e to the x times u, which is e to the x, all over
e to the x plus 1.
yeah, e to the x plus 1 quantity squared. And that's the answer. Are you going to see it like this? Is this simplified?
No.
No. So we had to simplify it. So this becomes e to the 2x plus e to the x minus e to the 2x over e to the x plus 1 squared. Those cancel each other out, and we get a final answer of e to the x over e to the x plus 1 squared. Boom, I'm done. Never expand the denominator. So we did a lot of examples here with e to the x, and most of the times you're going to see there's I'm finding the AP exam has a lot more e to the x's inside the exam, but the following is typically only one multiple choice question. All right, but it could be there. And that is, what is the derivative of a to the x? Now this is very similar to what we did, but it has to have a correction feature like we did log base a. So with log base a, we had a natural log of a that had to be in the denominator. Now I'm not going to go into the rules of algebra like I did for logs. So there's a rule that the reason why, if you want to know it, it's a little bit more pre-calculus if anything. But the derivative of a to the x is, we just put an extra natural log of a times a to the x. That's it. So the only difference is it has this correction term that's out in front. So you can do all the normal stuff you did times natural log of a. And therefore the derivative of a to the u, well, we know the derivative of a to the u, of e to the u, which is e to the u, or copy paste, right? I told you copy paste. So a to the u, we know that's going to be in the answer, times du dx, okay? But we have to have that correction. So if it's not e, all we have to do is slap on in front a natural log of a. It's the only difference. It's the only difference, and that is the main rule. Typically, when I see these on the multiple choice, they're very simple. It doesn't go very much. Here's our last example. F of x equals 4 to the 7x. Find f prime of x. Okay? So, copy paste, right? So, I know one of the things that's in my derivative. But there's going to be 3 parts of my derivative. So what is the derivative of, what is f prime of x in this last example? You can put the natural log of part in the front or the back. It really doesn't matter. You just got to make sure that it has that extra natural log. So what do I get?
Is a natural log of x?
No, it's always there was never natural log of x. It's always natural log of the base.
So natural log of 4. Okay. Times 4 to the 7x.
Finish it, finish it, finish it. There you go. Frida did it. Times 7. The derivative of 7x. Same process, copy, paste times derivative of the baby, but because the base is not e, you just have that extra little natural log of the base, natural log of 4. That's everything I have for you today. Complete your Delta Math homework assignment. I will see you tomorrow.